Chapter 7, Lesson 8, Generate Equivalent Expressions. So our learning objective is you will use properties of operations to write equivalent algebraic expressions to reorder, regroup, or rewrite the like terms. So we're taking Lesson 7 and adding to that. So the essential question is, how can you use properties of operations to write equivalent algebraic expressions? So just a reminder, equivalent expressions are equal to each other for any values of their variables. So for example, x plus 3 and 3 plus x are equivalent. So if I were to put in 1 for x plus 3, 1 plus 3 is 4, and 3 plus x, or 3 plus 1, is also 4. You can use properties of operations to write equivalent expressions. So these should all be reviewed. So properties of addition. Commutative property of addition is just saying if the order of terms change, the sum stays the same. So 12 plus a is the same thing as a plus 12. Or 12 plus 2 is going to equal 14, and 2 plus 12 will still equal 14. Doesn't matter the order. Associative property of addition says that when the grouping of terms change, the sum stays the same. So here they show 5 plus 8 plus b is still going to equal the same thing as 5 plus 8 plus b, but they changed the parentheses around there, okay? So if I had 5 plus 8 plus 1, doesn't matter where those parentheses are, it's still going to equal the same thing. Identity property of addition. One's probably the simplest. The sum of 0 and any number is always going to be that number. So no matter what number I plug in for c there, it says 0 plus c equals c. So 0 plus 5 equals 5. 0 plus 6 equals 6. Doesn't matter what number we add in there. Properties of multiplication. Commutative property of multiplication. So that one is saying if the order of the factors change, the product stays the same. X times 9, or d times 9 equals 9 times d. So 1 times 9 is the same thing as 9 times 1. Associative property of multiplication. When the grouping of factors changes, the product stays the same. So this is just like what we did up there for the associative property of addition. It doesn't matter where those parentheses are if we're only dealing with multiplication. Parentheses matter in order of operations, but if we're only multiplying the whole problem, parentheses don't matter where they're at. So 11 times 3 times e is the same thing as 11 times 3 times e. Okay? But if we have different operations in there, so if there's an addition, multiplication, subtraction, division, if there's something other than just multiplication signs, those parentheses matter. Identity property of multiplication. The product of 1 and any number is that number. So 1 times f will always equal f. 1 times 4 will always equal 4. 1 times 10 will always equal 10. Okay, that was all review. Now let's look at today's problems. So we're going to unlock the problem. It says Nelson ran 2 miles, 3 laps, and 5 miles. The expression 2 plus 3L plus 5 represents the total distance in miles Nelson ran, where L is the length in miles of 1 lap. Write an equivalent expression with only 2 terms. Okay, so we're going to rewrite the expression 2 plus 3L, which means 3 times L plus 5. And we're going to do that with only 2 terms. Okay? If you think back at what terms mean, which was in lesson 7, 4 maybe? Yeah, lesson 7.4, it says the terms of an expression are the parts of the expression that are separated by an addition or subtraction sign. Okay, so that means we should only have one addition or subtraction sign in there so that we can get it all the way down to 2 terms. So we're going to rewrite the expression. The like terms are 2 and 5. Okay, they are 2 and 5 because they don't have a variable. So that means those are alike. So we're going to use the commutative property it says the commutative property to reorder the terms, okay? Because if we're adding them all up, it doesn't matter what order they're in. So then we're going to take 3L plus 2 plus 5. Then we're going to use the associative property to regroup the terms. So we're going to have 3L plus 2 plus 5. Okay, because remember, associative means that it doesn't matter where those parentheses are as long as we're adding the whole thing. Now we're going to add within the parentheses, so we get 2 plus 5 equals 7. So an equivalent expression for the total distances miles is 3L plus 7. Again, we're down to 2 terms because we only have one addition sign left, and so there's 2 terms on either side, or 2 terms, 1 on either side. Okay, the last review of property is distributive property. So looking at distributive property, you need to remember multiplying a sum by a number is the same as multiplying each term by the number and then adding the products. So let me simplify that description for you. So it says, here is an example, 5 times, parenthesis, g plus 9 is the same thing as 5 times g plus 5 times 9. So you're just going to take that and just distribute that 5 times to both of those numbers in the parentheses. So the distributive property can also be used within multiplication and subtraction. For example, 2 times 10 minus h equals 2 times 10 minus 2 times h. So use properties of operations to write an expression equivalent to 5a plus 8a minus 16 by combining like terms. So for this first one, we're going to use the commutative property of multiplication to rewrite the like terms 5a and 8a. So we're going to use 5a plus 8a minus 16 equals a times 5 plus a times 8 minus 16. We're going to use the distributive property to rewrite a times 5 plus a times 8. So we're going to simplify that down by putting a times 5 plus 8 minus 16. Then we're going to add within the parentheses. So a times 5 plus 8 is 13. So a times 13 minus 16. Then we're going to use the commutative property of multiplication to rewrite a times 13 into 13a minus 16. So the expression 13a minus 16 is equivalent to 5a plus 8a minus 16. Example 2. Use the distributive property to write an equivalent expression. So we've got 6 parenthesis y plus 7. We're going to use the distributive property. 6y plus 7 is the same thing as 6 times y and 6 times 7. Multiply within the parentheses. 6 times 7 we know is 42. So now we have 6y plus 42. Now remember that that is equivalent to the other equation, or the other expression. So these two are equivalent. They would equal the same thing if we were to come up with an answer. And B, 12a plus 8b. So for this one, we're going to have to find the greatest common factor. The greatest common factor of 12 and 8 is 4. Because we have to think of something that we can multiply by a number to get 12, and something times 4 would be 8. So we know that both of them have factors of 2, 4. Those are the only things we have in common. Probably remember doing it as finding the factors 1 and 12, 2 and 6, 3, 4, and then you do the same thing for 8, 1 and 8, 2 and 4. And then we look for the largest number that they have in common. Okay, so the next step is we're going to write the first term, 12a, as the product. We're going to write that as the product of the greatest common factor and another factor. So we have 12a plus 4b equals 4 times 3a plus 8b. Okay, so again, we write the first term as the product of the greatest common factor and another factor. Then next we're going to write the second term, 8b, as the product of the greatest common factor and another factor, which is going to be 4 times 2b. Okay, so now we're going to use the distributive property. Since we're taking both of those and multiplying by 4, we can pull that out in the front. So we have 4 times 3a plus 2b. So the expression can be equivalent as 4 times 3a plus 2b.